We have witnessed our Hanover plant in Germany, where 150 tons of resin is manufactured per day by only 3 persons. Only 3 persons are involved in manufacturing this. So technology has gone far ahead, but it is, I believe, yet to come to India.
Is it the same story, Mr. Karkhanis, yet to come to India?
I would say, as one of the panelists said here, the purpose of making the foundry more productive is not making a manless foundry. Obviously, it defeats the purpose of employment. Today, we need to understand why it is becoming difficult for the foundry industry to employ a person. If he is getting the same wage and much cleaner environment, then obviously he will be preferring a cleaner environment in an industry like textile or maybe something else, machining. But what we are forgetting is, if our environment is going to be dirtier, I am saying even when we make our foundry extremely clean, even then it will be dirtier than possibly a automated machine shop. In that case, there is a need to understand that such dirtier environment has to be compensated by higher wages. And if the foundry has to afford these higher wages, in that case we have to become more productive. So foundry has to work for becoming more productive, either in core making, mold making, fettling and everything. We have to become more and more productive, then only possibly this industry is going to survive, because we get manpower. However, we cannot afford the salary that we need to pay them in order to retain them. That is very important, and that's why we need to work in productivity direction, and for productivity direction we need to take a number of steps which are very important.
Thank you. Any question from the audience?
I'm Samir Kelkar. I'm from Rhinemaster Machines Private Limited in Aurangabad. As a part of a new generation which has joined the manufacturing sector, I would like to voice an opinion that like the manufacturing industry, and in specific also the foundry sector, I believe it pays a lot lesser than other sectors do. Like when I was passing out of IIT Bombay in 2006, I was one of very few people who did not go for investment banking nor the consultancy fields. And when I joined my father's company, after half a month, I said to him, "Why have you hired me here?" Yeah, and the reason was, like, if you are going to not give me an engineer's job, why do you need me here? Luckily, the relation evolved from there on, and I was able to make the contributions in the company, like which I did in the last few years. But when we are hiring the new generation, like we have to give them a challenging role. Like we have to give them the role to modify things, to transform things. If you tell him to take an angle grinder and to do the fettling of castings, he is not going to do it. I'm not going to do it. Like I can speak for the new generation that like they are not going to do it. I'm also very happy to say that like recently we have developed a robotic cast iron fettling machine, like which is contributing to take out a hazardous job from the foundry sector.
This is Professor Ambegaonkar from IIF Pune chapter. Really commendable, special comments to Sanjay Karkhanis that whatever you have done, or a Kolhapur chapter have done at Kolhapur in terms of education and training, which is over and above what IIF has been doing it through Center for Education and Training. Pune chapter have definitely been taking a lot of efforts in roping up those working professionals to undergo this particular training. But you have achieved in a relatively short term to fulfill your requirements. But very important point which you have driven in your presentation is how the logic grows through this education and training. And therefore, a second step which Pune chapter have very recently done, which for the information of all who are here, is that we have roped in a new engineering college which have come up at Lonavala. We have, we have made them our member of Pune chapter. And with a kind of a experience which I had throughout in education, here the students will be getting their degree in engineering. And as all of you can appreciate, that mechanical engineers are required in much larger number in all the foundries. Today I am fortunate that I could get their principal and some 12 students from the same college who had shown interest in foundry after our interaction. And therefore, I would look forward that in next coming 3 or 4 years, the foundry industry should get good resource from this college with the help of all of you. The way you have experimented at Kolhapur, I wanted to share the efforts of IIF Pune chapter in this direction. So I am here. Thank you very much. All of you are invited to this new college, and I am associated with them only because of one thing, that this is a college which works for poor students. This is an institution which does not take any donation for admitting to graduate level. And the students will be getting their degree of Pune University as a BE Mechanical or BE Civil. I mean, they have a civil branch, mechanical and a computer. But I am looking forward to have a specialization as a foundry engineering in that college. So anyone who is interested in terms of human resource can anytime contact the college or IIF Pune chapter, because they are one of the members.
Can we take one last question before we head off for lunch?
Hello, this is Pramod Shinde from Minerals and Metal Review. In order to increase the skilled manpower for the foundry industry, can we have the majority consensus from the large audience sitting here today? Can we recommend the government to introduce foundry castings trade as in IIT or ITIs, which is the district level institute run by the government of India?
Just before you go for general consensus, I'll just update you on one thing. Maharashtra government, and possibly it must be done all over the country, like we have BA, BCom and BSc, there are new courses under BVoc, Bachelor of Vocational Studies. And this BVoc, they cover various lines in industry which are not covered by the education institutes. They have embroidery, they have graphic design, they have foundry technology also, and they have already started this. In fact, I am one of the member of Director of Studies for Shivaji University. For their 2 colleges have, in addition to whatever efforts we have put through Dhatu Tantra Prabodhini, the colleges have already, the 2 colleges have started this. So possibly what we have to do as an industry, we have to support these new Bachelor of Vocational Studies courses so that whatever the efforts have started, they become successful. We have to become participative in terms of course design, and we have also to become participative in terms of employing those youths. Thank you.
What is the benefits of high pressure molding machine? So we are looking new technology in the ferrous and non-ferrous metals. So since this Krishnan has mentioned about that high pressure molding machines, can I explain more about what is that?
High pressure, as I was telling, that when you are making a mold, high pressure per se is for the green sand molding or physically bonded sand. The bonding material is bentonite and water. Okay. Then only you have a sand grain getting bonded. So when you apply a high force, that is what, like 10 kg per centimeter square on a mold area, it is called a high pressure molding. The effect of it is that you get a much more harder mold.
Okay.
The mold will be much more, there will not be much of hard mold strength will be more. That is the advantage.
So it is suitable for ferrous and non-ferrous?
Now with your ferrous itself, if you're like Emerson, you're from Emerson group, right?
Emerson.
Emerson, yeah. Virgo is with you, right? Virgo
Yeah,
walls.
correct.
Like Virgo walls is for steel. It is mostly done with a chemically bonded. It is not with a high pressure bonding. Your Virgo walls in Coimbatore has got our equipment.
So it is suitable for bigger sizes also? Bigger size, more than 100 kgs.
Yes, chemically bonded sand, there is no limit. If you go to Laser and Tube, I mean, in India, Laser and Tube, Hazira, they make the turbine casing maybe 25, 30 tons, a single piece. But the number of castings will be limited. Per hour productivity will be less. In high pressure molding, with a vertical flaskless molding, it can go up to 500 molds an hour. Or flask mold, type flask molding, it could be 120 molds an hour. Beyond that is difficult, but it is mostly for a smaller casting, repetitive casting.
Okay, thank you.
Hello. Just to make the things simpler, possibly are you referring to steel castings?
Correct.
If you are referring to steel casting, one caution I must make, that if in green sand molding, we are talking about sand, bentonite and carbon former. Okay, so carbon former is always there, and whenever carbon former is there, in case you are looking for low carbon steel, in that case it is not conducive. So that is the reason why green sand based high pressure lines are not fully suitable for steel casting. Possibly some new technology may be developed, I do not know really, but this is the general view of the technology.
Friend, when you're talking of large castings, what size of castings are you talking? Size and weight?
We are doing single piece weight up to 700 kgs.
Size, approximately?
Approximately 1000 mm.
Okay. 1000.
1 meter, 1 meter.
1 meter, 1 meter. Okay. Let me tell you something that we have supplied. It's for railways. It's no secret. We have supplied equipment for railway bogies and bolsters. There we have box sizes of 3 meters by 1.5 meters by 500. That is, I'm talking of 3 meters by 3000 by 1200 by 1000. The casting weight is 450 kilos. The quantity of course required is very small. And this line runs presently at a speed of 6 moles per hour. It's upgradable to 12 moles per hour whenever they need it. And to answer Mr. Karkhanis's concern, yes, we have supplied a sand plant with that, which gives you facing sand and backing sand. Facing sand and backing sand from the same mixer in 2 different belts with 2 different outlets. So these things are possible. But when you finally come down to it, when you're talking of these smaller quantities, better finishes, higher productivities or outputs, what Mr. Krishnan is offering, the no-bake process, certainly makes more sense.
Which we are already doing with no bake.
So you're following the right process. I'm not a good salesman.
Thank you, everyone. That was a very absorbing session on molding and core making, actually. And we'd like to compliment Mr. Baum for his efforts on making the questionnaire and preparing the flow of the panel discussion. Can we have a round of applause for Mr. Baum, please? And may I now request Mr. Mahesh Kulkarni from Dorian Troop to present the mementos to our audience, to our panelists, please. इसमें ही था ध्यान दे Thank you, everyone. Dr. Rastogi is an environment scientist with over 30 years of exhaustive experience and knowledge in the field, and has authored several papers in metallurgy, foundry, mining, and other topics. Today, he will present on the scope for energy conservation in foundries. Sir, please.
Good afternoon, everybody, distinguished delegates and participants. It's very wonderful to be here and discuss about the energy efficiency. If you think about the foundry is just, you can't ignore that part, because whether it is a small needle or it's a big spacecraft, you need that thing. So ignoring foundry will be just impossible. You can't do that thing. And it goes very rapidly in the foundry industry. We know that thing, that it grows very rapidly, and it has grown in the past decade, and this is the first biggest procurer of metal casting in the world. And it employs, as on today, more than 2 million people. So we cannot dare to ignore this part. But at the same time, this is the most hazardous and polluting industry. That also cannot be ignored. So we have to take care of that part, because so many solid waste like slag, tailings, red mud, heavy metal, anode slimes, or toxic effluents like flue gases or thermal emissions, noise, they are all generated by the foundry industry. So can you imagine that sometimes we compare with the steel also, that if you had to generate one ton of steel through the blast furnace process, then it generates 3 tons of carbon dioxide, 1.2 to 1.4 ton of sulfur dioxide emission, and 1.8 to 2 ton of NOx. So that's remarkable. And again, if you think about the production of aluminum from bauxite process, so many hazardous substances are generated, like red mud, spent pot lining, fluoride emissions, and everybody knows that the red mud emissions, they have iron, alumina, silica, calcium, and alkalis, and fluoride emissions, they pose risk to all the living organisms, and the spot lining and electrode is also very harmful due to presence of cyanide. Now, and they affect all our flora, fauna, and terrestrial or aquatic ecology. I mean, there is no doubt about that thing. So what should we do about it? So we have to fix some short-term goals or some long-term goals. Short-term goals include, like, you can do energy audits of each and every process or every part, and then you can take decisions accordingly. Long-term part, you can think about changing the technology. So, but anyway, we have to think about using minimum use of fossil energy, or we have to find some alternative energy sources so that we can reduce dependence on energy. Can you believe that out of the total 10% of energy, 8.1% is used by the foundry and metallurgy industries. So that's a lot of energy, and we have plenty of scope for there. So that we have to think about. Steel we are not talking, but generally I can communicate that if we are using blast furnace source, then 31.1 GJ energy is used for steel making. If we are using another method like DRI, direct reduction of iron electric arc force method, then we are using 12.6 GJ of electricity. Again, if we are using smelting reduction, BOF and CC process, again it is 36.9, but at the steel as well as thermal, you are using both the things. So this is beneficial, like the one plant is there of JSW in Bellary. So, and POSCO had not come up so far, although the EC is accorded as early as in 2005. Now electric arc furnace is the another method where we use less energy, 2.4 GG energy for 1 ton of steel. But here mainly we are talking about the foundry. So let us think about the aluminum industry. The aluminum industry as on today, we are using approximately 257 GJ per ton of aluminum, but the best adaptable practices are 174. So we are using more energy than what is supposed to be required at the international level. So we have to think seriously how we can reduce. Another way in the aluminum manufacturing is the scrap, use of scrap. That's a wonderful method if we can get scrap, because then we are not using energy resources which we are using generally for manufacturing aluminum. Or we can say that only 3.5 GJ ton of electricity is used, per ton of electricity is used through the electric arc induction furnace. Or if we are using some other method, then maximum it is 14 to 16.5 when we are using oil furnace melting. So even then it is much less than any other method. And if you think about the foundry in general, now since morning we are talking about the energy efficiency and all that thing, I can just have a little glimpse about that thing, that what does it mean by green technology, because that is the term used for the foundry industry, which is most hazardous industry, and we are using the term green foundry, green technology. So this means that you have to think seriously about the reduction of energy, reduction of material waste in manufacturing waste, and reduction of energy in the manufacturing process. Only then we can think about the green foundry or green technology. Let us go through one by one. Let us do the post-mortem of foundry, what we are thinking since morning. But I'm really surprised that everybody is conscious about that thing, and everybody is thinking positively, because there is no other way out. If you think about